In front of you there is a question, and name of this lecture is written. Name of this lecture is this astronomy. It is a standard of 8th class. We took a chapter. We took a chapter. In this, our focus will not be on discussing uh, concept regarding we have some question based on this chapter. Okay, yeah, I will make a separate lecture on concepts of this lecture, but in this I tell you that we will have some question based on this lecture. Now there is a one question which is written over here. We are going to solve this. I want to ask you, what process would you follow here? What do you think about this? What do you think? Here, first of all, look at this question. Read this question carefully. If you are getting clarity, then you are able to move to next step, to take next step. Here, we have minus 2 upon 3. Then multiplication, then 3 upon 5, then addition, then 5 upon 2, minus 3 upon 2, multiplication, then 1 upon 6. Like that we have question. Just a simple method, whatever you know, simple method, apply that method. Okay. Here, it will become what? Look here, answer should come 2, logically. So it will become minus 6, it will become 15. Then what else? We have 5 upon 2 minus 3 upon 5. Then now you can say 3 1 are 3 and 6 5 are 30. Okay? Now ahead of it, what what ahead of? Just we have fraction. 15 to 30. Clear? 2 sevens are 2 ones are 2 15 twos are. Then 3 fives are 5 7 7. Look at here. 3 2 is 6, 6 5 are 30, and 35 is 35 is 2 3 is 6, 6 5 are 30, 37 are 210. 210. This much we are getting. Look at this. This is rule. It is known as a rule. Here, look at it. Rather than doing like that, you can skip this because we are getting this much. First of all, let's simplify this to fraction. This to fraction. Here we have 15 to the 15 to the. So here, what is happening? 15 has it 1, 3 5s are. So 5 3s 2 3 is 6, 6 5s are 30. So it is coming as a 30. Now 15 twos are, so 6 twos are 12. Here, look at here, 15 twos are, so 55s are. 55 is nothing but 5 5s are, then 2 5 7 75, and we left this much. Just to simplify this, you will get something 75 75 minus 12, 3 is 6, 63. You are getting this much, 63 upon 30, and then you have this 3 upon 30. Now look at here. Look at here. 30, this is the same, it will become 30 and denominator, and in numerator will be written as it. We are getting this. You can say 32 is a 60. 2 came as our output, and here you can say we brought this to answer by simplifying it. That is how you will solve. Okay. Just it was a very simple method, I know, and in that question, during this lecture, we will have very simple, basic question. Look at this, then I will erase it to write next question. Now let me write the next question, which is nothing. Look at this question. Simple method you will apply here. As you know that it will give us this multiplication will give us minus 6, and this in denominator 35. Then minus here 3 1 the 3, 3 2 the 12 6. Then 2 2 the 1, 4 2 the 20, 5 4 the 20. Now first of all addition, then subtraction. First we need to simplify addition fraction. Okay? Look at over here, minus 6 upon 35 will be as it. Now what about this? Minus, okay? Here look at it. 12, 20. 12, 20. 2 6 are 2 10s, 2 3s are 2 5s, 3, okay. Look at here, 2 to the 4 and 4 to the 12, 12 5s are 60. 60, it is giving us 60. And 12 5s are, so 3 5s are 15. Plus 23 is there, so 3 2 is 6. It is coming that much. Now minus 6 upon 35 will be as it, because of we need to simplify this in numerator. So minus 50 plus 6, I think it should be 11, minus 11. Minus 11 upon 16. Minus 11 upon 16. Okay, now what else? What else? We need this much answer. This much. So here we can say 60, 35. 2 30, then 35, 2 15, then 35, 3 5s are, then 35, 5 1s are, then 7. 2 2s are 4, 4 3s are 12, 12 5s are 60, 67s are. It is coming 0, 42, 42, 420. 420. Something happened. Something is wrong. Look at here. Now, as we know, 35 5 no 350. I think it will be difficult to solve it. Look at here. 2 to the 4, it will cut. Okay. Then we have this much. 3 to the 6, 35 is 2 upon, then 2 upon. 2 upon 5, then 2 upon 5. We have. In this case, so 2 upon 5, 2 upon 5. Okay. Minus 6, 35. Then minus 6, minus of 3 1 12, then 2 10. In that case, let's say 35. Look at over here. First of all, addition. So it will give us 7 12. 2 5s are, then 2 6s are, 2 3s are. 2 to the 4, 4 5s are 20, 23s are 60. 60. It is becoming this much. 60. So 12 5s are, 3 5s are 50. Plus 10 6 are. So 12. It will become 12. Minus 6 upon 30, and it will give us minus 3 upon 60. Look at here. What is happening? It is cutting this. So 3 to the 6 and 0. Minus 6 upon 35, 1 upon 20. 1 upon 20. LCM of this would be 35 20. 35 10, 35 5, 5 7 the 1 7. 2 to the 4, 35. 35 4 the 4, then 2 4 to the 4 3 the 12, 40. 140. 140. 140. Okay. Then 35s are, it will be 5 3s are 15, 15 and 16. So I think by 4. Okay, 4 3s are 12, 12 and 2, 60, 12 out of 40. So 35 4s are 140. So 6 4s are 24 minus 7s are. So 7 1s are 7. Now look at over here. It is giving you how much? Minus 31 upon 140. This much. This is for you. You will have to bring this much answer. Okay, this much answer. This is for you. If like that answer is not coming, so one method more we can do. We can do one method more. Here you can see 2 upon 5, it is in multiplication. Again here 2 upon 5 is present over here. So both are in multiplication. So both are same. If both are same, we can take it as a common. So look at over here, 2 upon 5 multiple minus 3 upon 7. Okay. So here we have this plus 1 upon 4. 1 upon 4 multiple 2 upon 5 minus, okay. So here 3 upon 2. We will take it as a common, 2 5 upon. Okay, here look at here. Now can we write 3 to the 6 and 35, 1 upon 4. So it is becoming not 1 upon 4, then 1 upon minus 6, it is becoming 1 upon 2 to the 4. Because 3 upon 12, 3 4 yeah, look at over here, minus 6 upon 35. So addition subtraction, minus 6 upon 35, 35 comma 4, 35 2 to the 4, 2 35 1, 5 7 2 to the 4, 4 to the 4 5 20, 140, again 140, 4 24, then plus 20, 4 to the 12, 40, 24 and then plus 35, 1 upon 4, 9, 140 plus 104, 0, 4 4 the 16, 1, 1, 5, 36 plus 140, it is giving you 176 upon 360, 28 5s. 4, 5 to the 10, 10, 14, 114. This is for you. Okay, this is for you. This is for you. Somehow you will have to answer this much. Minus 11 upon 28. Now next question, let me write. look at it. Read this question carefully. Read this question carefully. Look, this is for you, okay? This is for you. One question is for you. Write the additive inverse of each of the following. Additive, which means positive. Additive, which means positive addition. Uh, we have this question. What would be additive inverse of this question? We have minus 5 upon 9. Whatever you are observing negative sign, just convert that negative sign into additive, into positive. Okay, into positive. And whatever you are observing a number which is with a positive, let it be as it. For example, here minus is in a numerator, so we will convert this. Answer will be what? 5 upon 9. 9 is with a positive, it will be as it. Just whatever is a number with a negative, we will have to convert that number into positive. Because of question is saying write the additive inverse. So opposite of this would be what? Opposite of this would be this much. Now look at this here. So opposite here you can see you are observing two negative signs. Just convert this to negative sign into positive. You will get 6 upon 5. Now we can clearly see that yes, this is the opposite of this. This is the opposite of this. In operators, here we have positive, negative. In this we have positive. Now look at this. 2 upon 9. That's it. 2 upon 9. Here 2 is with positive. It will be as it. Then 9 is in negative. So we just converted 9 minus 9 into positive. Now next question we have. Minus 19 upon 16. So it will become 19 upon 16 because of 16 is in a negative. We just converted minus 16 into positive, and 90 is already positive. 90 is already positive. If we convert 90 into negative, then we will not have additive inverse. Additive. We are not saying inverse. Question is not saying inverse. Question is saying write the additive inverse of the question. One is for you. Now next question. This is the next question. It is different from the previous. we will have to enter input, then we will get output as a 0. Do you want to say magic? Look at this question. Read this statement carefully. It is saying verify that if you have minus into minus x is equal to x for this. Here it is telling you have a given value of x which is 11 upon 5. You will have to enter this value of x into this, then simplify it. Whatever you are getting, if you are whatever you are getting, just look at this. We have this minus, then minus x is equal to x, minus as it minus, so x is 11 upon this much, and then we have this 11 upon 5, 11 upon 5. What is happening over here? It is becoming 11 upon 5. Then when it will come this side, it will become that much. Now you can see it is equal to 0. It is equal to 0. So here answer would be nothing but 0. This is 0. Same here, same for this question. Same for this question. Look at over here. We know that this is equal to this. Why this left hand side is equal to RHS? Because of it is becoming positive x. When we will simplify this, then it will give us a plus x, and both are same. That's why both are same. Here look at it for this question. Minus, okay, minus, then minus, we have this. So already we have a minus 13. It will become 13 upon 13, and then we have minus 13 upon 17. Now our work is to simplify this. In first step, we just substituted value of x. Now after substituting, we are observing that we need to simplify this. So just simplify this. Look at this here. It will become minus 13 upon 17, and it is already minus 13 upon 17. We don't need to simplify this RHS. Now look at this. Both are same. In that situation, when it will be brought in this, so it will become plus, and it is equal to 0. What is happening over here? This is the same, and minus 13 plus 13, it is becoming 0. You can see what is happening over here. So answer is coming as a 0 as a output in both cases. That is what question was asking. Question was saying verify that. Verify, which means you have given this much, okay, and you will enter this into, and you will have to verify that this is equal to this, okay. This is what you have to verify by the question. Now let me write next question. Next question is very simple. You will enjoy. read the statement. What is the statement saying? Look at this question. It is very simple. In the previous we saw additive inverse, but in this we are observing multiple inverse. So what is the meaning of a multiple inverse? We will have to convert numerator into denominator and denominator into numerator. We will not care about the positive and negative sign operators. Positive operator, negative sign. We will not care. Just we will have to inverse. Just we will have to convert a denominator, numerator both. Here you can see, here we have in the first question we have minus 13. We have minus 13. You can see minus 13 is in a numerator, it is not in a denominator. So we will have to write it in denominator. And in numerator what will be 1. So operators will be as it. We are not caring about this operators because of this multiplicative inverse. So minus will be as it is and opposite this would be 13. This is done. Now next we have over here. Next we have look at just convert numerator number into denominator and denominator number into numerator. So 13 is a numerator. 13 will come into denominator and 9 will go in place of numerator. So 9 over here and operator will be as it, 30 as it. That's it. Now in this look at it. 5 will go in numerator and 1 will come in denominator. So as now it is also written as 5 upon 1, but here 1 is a hidden. Okay, 1 is a hidden in denominator. Now next question. This is the answer. Okay. Now next in this, look at this. First of all, we need to simplify this because it is giving us an option to simplify it. That's why we cannot say directly from this because it can be confusion. It can be incorrect answer. Our answer can be incorrect. After simplifying it, you will get exact answer. Right answer you can say. So here it is giving us how much? 15, and this is becoming 8 on the 56. Now we have we need to just convert this upon this. It is. So we just converted this into this into this. Now for this we know that it will become 2 upon 5, and it will become multiplicative inverse of this will be 5 upon 2, and this would be what? This would be minus upon, so of course it will become minus 1 I think, because it can be written as like that. So it will be both meaning of this and this both are same. Look at this. It was very simple. I don't need to explain more about this. Can I move ahead of this? Now next question. I can write over here. This is our question. It is telling you read this statement. First work is to read this statement. Multiple this by this reciprocal of this. This is not a reciprocal. We will have to convert this into reciprocal. So reciprocal of this would be what? We don't need to care about operators. Just denominator care about denominators and denominators in the case of reciprocal. Look at here. So reciprocal of this would become 6 upon 7 minus would be as it minus would be as it. Okay. Now we are going to multiply this by this 6 upon 30. 6 upon 30. After simplifying it, we will get minus 36 upon 13 sevens are, it is nothing but 91. It should be 91. 1 and then 2. So it is giving us 91. This was our answer. This is our answer. In this question, our focus was on this. How to convert any fraction into reciprocal. Just we will not care about operators. Just we need to convert the number which is in a denominator into numerator. Number which is in a denominator into denominator. That's it. Minus 36 upon 91. Just have a look. Now next question. Read this. Read this question. Here is 8 upon 9. The multiplication inverse of this is this multiplication inverse of this. Look, to check it, if multiplication of this and this is giving 1, then we can say yes, this is a multiplication inverse of this. Here, look at here. I have this, okay, this, and I am saying multiply multiplication inverse of this would be what? Just opposite 6 upon 5. Just we will convert this into opposite, denominator will come here and denominator will come here. Now what is happening? What is happening? It is giving us how much? 1. How much? 1. So can we say when we will multiply this by this, will come 1 as output? As output. Okay. Here, if you take next another example, for example, minus 5 upon 6, minus 5 upon 6. Now, multiplication inverse of this would be what? Minus will be as it. Okay. Just 6 will go in up and 5 will come down. What is happening over here? Minus minus will become positive. And here 5 will cut 5, 6 will cut 6. It is becoming again 1. Same here. Multiplication of this and this should come 1. Should come 1. After converting this into multiplication inverse. Yeah. Look at it. So as you know that this is a mixed fraction, we will have to convert into simple fraction. Okay, into simple fraction. So first of all, simplify this here. Minus upon and 1 upon it. It will become 8 ones are and 1. 1 is a this. It is a reminder. So 9 minus 9 upon 8. Okay. Now, as we know, 8 upon 9 multiple minus upon 8. Now, what is happening over here? This is cutting this is cutting this. But we are getting minus 1, not 1. Minus 1 and 1, both are different. Both are very different. Okay. So it is not giving us 1. So we can easily say that this is not a multiplication inverse of this. Okay. This is not a multiplication inverse of this. Clear? Next. Next is that read this question carefully. Here we have multiplication inverse. If a multiplication of this and this is becoming 1, then we can say yes, it is a multiplication inverse of this. Now we can write it. It is an addition. We can convert it into fraction. It is equal to 3 upon 10. We know. So 3 upon 10 multiple 3 3 is 9, 9 plus 10, 10 upon 3. If this is giving 1, then we can say yes, this is a multiplication. 0.3 is a multiplication inverse of 10 upon 3. So yes, it is giving us 1. So we can say yes, this is the multiplication inverse of 10 upon 3. That is how you will solve. Now next question. Next question is here. How would you like to represent this fraction on number line? Do you have any idea? Look at here. We have 7 upon 4. 4 is the denominator. If you will write here 4 upon 4, it will become 1. It will become 1. So 1 is coming between 0 and 2. 0 and 2. And it is going ahead of 1. Can we say that it is becoming like that? Oh, look at it. 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5. What is happening over here? Look at here. Rather than writing like that, we can write like that only. Here, let's say 0 is over here, and this is giving us how much? This is giving us 1. 1. We have here 7 upon 4. If we start here, 1 from 1 upon 4, 1 upon 4, then 1 upon 2 upon 4, then 3 upon 4. Here it will become 4 upon 4. As you know that 4 upon 4 is a 1. Ahead of this will be what? 5 upon 4, then 6 upon 4, then 7 upon 4, and then 8 upon 4. 4 to z, it will become 4 to z. So this 2 will come over here. We can see our this fraction is coming over here, 7 upon 4. That is how you will represent any fraction. Okay, any fraction. That is all. Okay, what about this? What about this fraction? Look at here over here. We know that if we here write 6, then it will become minus 1. Minus 1. So can we say it is just behind minus 1. So 0 over here. We will start from here. Minus 1 upon 6. Then minus minus 2 upon 6, then minus 3 upon 6, then minus 4 upon 6, then minus 5 upon 6, then minus, look at over here, minus 6 upon 6, it is becoming minus 1. So of course 1 will come over here, 1 will come over here. Now between 0 and this is not a 1, this is a minus 1. Between 0 and minus 1, our this fraction is coming. Where? Over here. In this, what was happening? Between 0 and 2, this fraction was coming over here. That is how you can plot your fraction on number line. On number line. Just think carefully. Think critically. Okay. Is it making sense or not? Of course it is making. How is it making? We know that this is equal to this much. Of course. And here we started from here. Minus. If we write here, this 0 can be written as 0 upon 6. And it will give us how much? 0. It will give us 0. Then 0, then minus 1, then minus 2, minus 3, like that. We went till here, we will keep going until we get minus 5 upon 6. So minus 5 upon 6 is coming over here. Is coming over here. It will be continuing. Then we will write minus 6 upon minus 7 upon 6, then minus 8 upon 6, like that. Okay, we know that between any two integer numbers, there are infinity rational numbers. That is a truth. This is a truth. Are you crystal clear about it? Can I move ahead of this? Our next question, let me write. Look at this. Always remember, one fact more I would like to tell you. If a denominator number is greater than numerator, if a denominator number is greater than numerator, in that case, this number will come between 0, fraction will come between 0 and 1 or 0 and minus 1. If a denominator is greater. If a denominator is greater. Now, we have this much of fraction. We are going to plot this on a number line. How to plot? How would I like to plot? You can see here over here. We will draw a number line. Okay. Here we know that all these are in negative. We don't need to take a positive. So 0. Let's say 0 is over here. Now, a 0 upon 11. 0 upon 11 will become 0. Okay. Then we have 1 upon 11, but it is in negative. Then minus 2 upon 11, minus 3 upon 11, minus 4 upon 11, then minus 5 upon 11. So we got this and this. Here you can see minus 2 upon 11. Okay. Ahead of this, minus 6 upon 11, minus 7 upon 11, minus 8 upon 11, then minus 9 upon 11, and then minus 10 upon 11, then we are getting 1. We are getting 1. because minus not 1 minus 1. So we our this fraction where here, okay, and this minus 5 upon 11 over here, and minus 9 upon 11 over here, over here. Like that you will plot. You are saying that minus 2 upon 11 is over here, minus 5 upon 11 is upon here, and minus 9 upon 11 is coming over here. That is a correct way to represent our fraction, our rational numbers on number line. It is very easy to plot integer numbers, but when it comes to rational number, then most of you would get confused. Most of you would say, I am not able to present this fraction on a number line. But trust me, it is a very easy if you understand it carefully. Then first of all, you will have to take knowledge regarding, you will have to clear understanding about concept of this lecture. Then you will be able to plot this number on a number line. Okay, I am going to write a next question. Just have a look. Next is a little bit different from this, but not more different. Can you solve this? We don't need to solve this. It is telling me that write 5 rational number, not integer, rational, which looks like a fraction. Yes, it is the exact fraction, but not a mixed fraction. Okay. Write 5 rational numbers which should be small than 2. We know 2 is an integer, and we will have to convert this 2 into rational number. So rational of this 2 will be what? It can be 10 upon 5, isn't it? 10 upon 5. Now it will give us 2. 5 to the 10. It will give us 2. Okay. So it should be less than 5 rational number should be less than this rational number. So less than it would be 5 upon 9. Then 8 upon 5. What would it? So our answer is nothing but 5 upon 9, 5 upon, hold on, 9 upon 5, 8 upon 5, and 7 upon 5, then 6 upon 5, then 5 upon 5. Or you can say 4 upon 5. All these are rational numbers which are less than 2. You can see. Okay. It can be written as 20 upon 2 because it is also giving us 2. And less than of this would be what? 19 upon 10, then 18 upon 10, 17 upon 10, 16 upon 10, and then one more 15 upon 10. These are 5 rational numbers which are less than 2. You can write this, either this or this. It's your choice. Both are correct. Both are correct. Both are rational numbers which are less than 2 integer. 2 integer. That is how we find a rational number between before any integer. Now next I have next is a little more bit different from this. Look at this. It is very. I know it is looking difficult, but we will have to understand then solve it. Uh, After reading this, we are understanding. Find the rational number between 2 up minus 2 upon 5 and 1 upon 2. Here denominators are not same. Denominator numbers are not same. That's why we are not able to find out directly rational numbers between this. Yes, between this. So here we will have to make denominators equally. Then we will able to find the rational number. So one thing can be done is that minus 2 upon 5, okay, and 1 upon 2. To convert this into a number, we should be equal to this denominator. Can we say that it here should be 2 and here should be 5? And here, if we are multiplying this 2 by this denominator, same we will do here. Same here. What is happening over here? It is giving minus 4 upon 10 and it is giving us 5 upon 10. Now our denominators in the both fractions are same. We are able to find the rational number between this. So look at over here. Yeah, there are a lot of rational numbers between this because of this is a minus 4 and this is a 5. This is 5. Okay, that's it. Can we say what? Here look at it. We have minus 3 upon 10, minus 2 upon 10, minus 1 upon 10, then 0. We can write it as a 0 upon 10. Then we have 1 upon 10, then 2 upon 10, then 3 upon 10, then 4 upon 10, hold on, 1 upon 10, then 5 upon 10, then 6 upon 10. Look at here. Look at here. These are those rational numbers which are coming between this 2, minus 4 upon 10 and 5 upon 10. Look at here. No. 5 upon 10 it will give us 1 upon 2. Okay. That is how you will find any rational number between any rational number. Okay. And you can also find rational number between any integers. In this question, we found some rational numbers between given rational numbers. But in upcoming question, you will be able to find any rational number between any integers. Okay. So that's all in this. I will take next lecture in which we will be discussing something else.